Probability and odds of an event. Lucas Jacobson, Full Sail University. When talking about the probability and odds of an event, we must first break down the difference of the two items. 1. What does the term probability mean, and how do we find out what the probability of an event is? And 2. What does the term odds mean, and how do we find out the odds? As a sports enthusiast, and with a major of sports marketing and media, we'll use my favorite sport to break down each one of these items, concepts that I wish I had paid more attention to in high school. If I had, then maybe someone would be writing a paper about me instead of the other way around. First, to define the two terms, we look towards our McGraw-Hill ebook section 9.6 from alex.com and find that the probability of an event measures the likelihood of the event to occur. Alright, so it measures the likelihood of an event to occur, but how? As we delve further into our ebook, we find the equation that breaks down the probability so we can take a deeper look. McGraw-Hill shows that the probability of an event is equal to the number of elements in event divided by the number of elements in a sample space. So let's look at New York Yankees pitcher Masahiro Tanaka and the 7 possible pitches he throws, which include 4 different fastballs, a split finger, 4-seam, sinking, and cutter, and 3 off-speed pitches, the slider, the curveball, and the changeup. We'll use the number 7 as Tanaka's number of elements in a sample space, which is basically saying the total number of possibilities. If Mike Trout were up to bat and he wanted to know what was the probability that Tanaka would throw a first pitch fastball, the equation would look something like this. The probability of a fastball being thrown is equal to the number of fastball pitches at Tanaka's disposal, 4, divided by the total number of pitches Tanaka throws, 7. 4 divided by 7 is already in its simplest form, but if we want to look at it from a percentage standpoint, we would do the same math. We would do the simple math and see that it divides into 0.5714, which would amount to 57% of the time. With the basic concepts of probability laid out, let's look at how odds can help Mike Trout get a hit off of Tanaka. Looking at, again, basic mathematics by Krugolek, it is seen that the odds are defined as the ratio of desired outcome is the ratio of probability of its success to the probability of its failure. Since we already decided that the probability is favorable to a fastball being thrown, we'll look at the odds of which fastball. A common pitch to start in an at-bat is the 4-seam fastball, so we'll look at the odds that Tanaka will throw this pitch. We know that Tanaka has 4 fastball pitches, and if Trout is guessing that the first pitch is a 4-seam fastball, the probability of success, we'll say, that leaves 3 other pitches Trout could be incorrect with, or the probability of failure. The odds would then be 1 to 3 that the fastball is a 4-seam fastball. Anyone in the sports marketing industry would tell you that Trout takes more information into factoring his decision leading up to his swing, such as combining the items we talked about with the history of the pitcher and the count of the at-bat. Yet the basic concepts are all the same. A person in the internet marketing industry would use the same concepts in deciding where and how to market. If a marketer were to compare 2 sites to figure where to market their product, they could simply look at how many visitors each site had in the previous day, week, year, or etc. If Site A has 1,000 visitors per day average, and Site B has 250, it's easy to break down that the odds in which Site A would reach 100,000 buyers first would be 1,000 to 250. Or it would be simplified to 10 to 2.5. With Site A averaging 1,000 visitors per day, the probability it will reach 10,000 visitors in a week would be about 70%. 7 days times 1,000 visitors per day divided by 10,000. Again, I am using a very simplified version of these concepts, but they start here. Where did all these concepts come from, and who is responsible for helping Mike Trout to become one of the best young stars the game of baseball knows today? Well, history points us in a few different directions. We can go back as far as Dante Alighieri and the Divine Comedy, where Dante speaks of a dice game called Hazard, which was played with 2 or 3 dice, in which the game is so confusing that all any player can do is play the chance of a certain dice, or better yet, the probability that certain dice are thrown. You could use the concept of odds also and ask what are the odds that a certain number will be thrown. With 216 possible combinations, or 6 to the third power, on three dice, and only one possible outcome to throw a number 3, which would be a 1 on each dice, the probability is equal to 1 outcome divided by 216 possibilities, or 0.005, which is 0.5% of a chance. The odds in favor of throwing a 3 would be 1 to 215, which is 1 positive outcome compared to 215 negative outcomes. Elementary Statistics by Alan Blumen gives us the names Jacob Bernoulli and Carl Friedrich Gauss as 2 of the individuals credited with presenting probabilities and odds to the mathematical and scientific communities. Bernoulli's Art of Conjecture gave the theories sound footing for the mathematical community, while Gauss introduced Europe to such theories from a scientific perspective, in which he predicted the probable path of Ceres, which is the largest object in the asteroid belt between Mars and Jupiter, and helped astronomers recover the lost object after they had lost track of it. There are many possibilities for the use of probability and odds. In fact, the 2 concepts are very much entwined, as you can tell. The game Hazard gives us a small glimpse into how the gambling community is affected, while the same works in sports in predicting winners. Almost every sport can use the same probability and odds from a gambling perspective, as well as the decision making within the sport itself. For the record, as of today, May 24, 2014, Mike Trout has a .276 batting average, with 10 home runs and 33 runs batted in, which shows that he has not been using probability to the efficiency that he has the past 2 years, in which he batted over .300, but is still doing pretty good. Gauss has given us a scientific look into the use of each, which inherently leads to the predictive path of all planets and objects in space. Without these predictions, I doubt Neil Armstrong or Buzz Aldrin would have ever landed on the moon. Probability and odds are great concepts and have been helpful in many aspects of life, and will prove to be so for the future. In fact, Mike Trout just put another ball into play for a hit. It's helping him already.